Hello students, today we will be discussing chemical kinetics and in that important topic order of reactions and related formulas. See, quite frequently in NEET exam we will see questions on first order and zero order reactions. Mainly among them first order questions quite frequently we see how to find the rate constant, how to find the half-life. These are the questions which we frequently come across. Today we will discuss first some theory we will discuss on that, and then we will see various model of problems on that. See, these are the formulas of zero order, first order and second order. Most important is zero and first order. Very rarely we see question on second order, but anyway it's better to remember the formula for that as well. Zero order reactions. In zero order reactions, rate constant formula is initial concentration of reactant, focus on only reactant, not on the products. Initial concentration of reactant minus final concentration of reactant divided by time. That is R naught minus R by time. That is the zero order rate constant formula. Half-life. Half-life formula of zero order is just initial concentration by 2 into K. 2 R naught by 2K is the half-life formula. And if you see here, half-life is directly proportional to the initial concentration. Keep that in mind. Next, come to the first order related formulas. First order rate constant formula is 2.303 by time, T means time, logarithm of initial concentration by final concentration. See, this R naught and R, remember denominator R means final concentration of reactant, how much concentration of reactant remaining at a time T, that we have to take in denominator. Sometimes students take wrongly in the denominator here inside logarithm. They take denominator as how much reactant has reacted. No, don't take the how much reactant reacted. Numerator is how much initial reactant substance. Final denominator is what is the final reactant remaining at time T, not reacted. Keep that in mind. Half-life is formula is 0.693 by K. Here there is no initial concentration term anywhere. Therefore, can I say half-life is independent of initial concentration in the first order reactions? Yes, I can say independent of initial concentration. In second order, rate constant formula is 1 by time into 1 by final concentration of reactant minus 1 by initial concentration of reactant. Similarly, half-life is 1 by R naught into K. So here initial concentration and half-life are inversely related. So that's why we have written here half-life is inversely proportional to initial concentration. So if you see, there are three different formulas for rate constant, and also there are three different formulas for the half-life for these three order reactions. Most important is first order, second important is zero order, least important is, which we come across in exams, is second order. Now, so in zero order half-life is directly proportional to initial concentration. In first order it is independent of initial concentration, inversely proportional to initial concentration. Keep that in mind. Next, in first order reaction, which of the following are independent of initial concentration of reactant? Now let's look at this problem. In the four options, we have to select which is independent of initial concentration of reactant. Here, this is a multi-choice correct question. So multiple options may be correct here. Just to have more clarity, I have given question like this. Now see, in examination only single choice correct we will come across, but here it is a multi-choice for better understanding. Now, first is rate constant. See, rate constant does not depend on any concentration term. Remember, rate constant, that's why we say it is constant. If it depends on the concentration terms, we don't say the word constant. So, rate constant is anyway independent of initial concentrations or any concentrations. So, this is correct. Next, half-life. Half-life of first order reaction, we know the formula, which is independent of initial concentration. So, this is also right only. Rate of reaction. See, rate of reaction can be written as rate constant into concentration of reactant power order. Since we are dealing with first order question, we can write this as K into reactant power order 1. So, rate of reaction is depending on the concentration of reactant. How can we say it is independent? It is clearly visible it is dependent. Therefore, this is wrong. Next, order of reaction. For a given reaction, order is fixed. It won't change for a given reaction. No matter whether you change temperature or concentration of reactants, it does not affect the order. Order is fixed only. When you go to different reaction, order may change. For a given reaction, order is fixed. Therefore, it is also independent of initial concentration. Next, we will see another question. A gives to B. Now here, K is given as 0.2 molarity per second. Initial concentration of A is 10 molarity. Find A and B at T is equal 10 seconds. Now listen carefully. In this question, nowhere they have mentioned what is the order of reaction. And that is more important for us. If we don't know order, how do we know which formula to apply? First, we need to figure out the order of reaction. How to figure out? Remember, suppose if order of reaction is 0, then unit of rate constant. Unit of rate constant will be what? It will be, if order is 0, unit of rate constant will be molarity per second, or molarity you can write moles per liter per second. Suppose if order is 1, then first order reactions, unit of rate constant is simply second inverse. There is no molarity term will be there here. Suppose if it is a second order reaction, then mole inverse liter second inverse. That means you can write this as molarity inverse second inverse. So, if there is a molarity second inverse, then I remember it comes under the 0 order. So, units of rate constants will give us hint which order the reaction comes under. So, in this problem if you see, clearly it is visible the rate constant units are molarity second inverse. Means which order reaction it is? 0 order reaction. They have not mentioned anywhere the word 0 order, but units indicate 0 order reaction. Now, in 0 order reaction, what is the rate constant formula? K is equal to R naught initial concentration of reactant minus final concentration of reactant by time. This is the formula. Now, initial concentration is given as 10 molarity and find final concentration of reactant. So let's substitute in this and find. First, let's simplify this. R naught minus R is equal to KT. So you can write R is equal to R naught minus KT. R naught is given. How much is initial concentration? 10 molarity. So 10 minus K value, constant value is how much? 0.2. 0.2. Time is how much? 10 seconds. So after substituting this, then K into T, 0.2 into 10 is 2. 10 minus 2 is 8. So final concentration of reactant value is 8 molarity. This we got. Next one, B. The B means what here? If you see the reaction, it is not the reactant, it is the product. They are asking product value also at time 10 seconds. Now, we know A gives 2B. That is a reaction. That means, can I say moles of A reacted, moles of A reacted or molarity of A reacted will be similar only. So I will take molarity of A reacted divided by stoichiometric coefficient is equal to molarity of B reacted, B formed, because B is forming. So whatever B is forming, molarity, divided by its stoichiometric coefficient is how much? 2. Such relationship is valid for mole problems in the stoichiometric calculations of chapter stoichiometry. Similar way we can do it for the molarity also, because A and B are in the same beaker, so volume is same for both of them. So in place of moles we can use molarities and we can use such relationship. Molarity by stoichiometric of reactant is equal to molarity by stoichiometric of the product. Now, how much is reacted? See, initially 10 molarity we have begun with. Finally, how much is there? 8 is remaining. Then how much is reacted? 10 minus 8 is the reacted molarity divided by 1 is equal to B formed divided by 2. Therefore, B formed is how much? 10 minus 8 is 2. 2 into 2 is 4. So, B formed is 4 molarity. This is how we will solve the questions on this. Next, let's go to another model. See, A gives 2B. A naught is again 4 molarity, A is 2 molarity at 10 minutes. At 10 minutes, concentration of reactant is how much? 2 molarity. Initially, how much we began with? 4 molarity. Find K. K means rate constant in minute inverse. Now, we may think, sir, this is as similar as the previous problem only. But it is similar to previous problem, but formulas what we use here is not same. Why? Because, see, if you see the unit here, they are asking what is the rate constant unit, what is the rate constant value in minute inverse. Minute inverse or second inverse. This time inverse is the unit of which order reaction? First order reaction. Molarity time inverse is the unit of 0 order. Only time inverse is the unit of which order? First order reactions. So this is first order. They have not mentioned anywhere in the question. We have to understand from the units of the rate constant. Understand that. Okay. Now, how to find K of first order? What is the formula we know? 2.303 by time log initial concentration of reactant by final concentration. Now, time is given in the question? Yes, 10 minutes. Initial concentration? Yes, 4. Final concentration? 2. All are known. So, let's substitute that. 2.303 by time is how much? 10 minutes. I'll take 10 into 60. Why? Because 10 is the minutes. Time is given in minutes. But they are expecting, they are expecting answer in minute inverse. So, minute inverse means keep it in 10 only. Suppose if they expect answer in second inverse, then convert that time also in seconds. But here in the question minutes only they have asked. So, let's keep it as 10 only. Don't convert into seconds there. Next, into logarithm R naught by R. What is R naught? Initial concentration. How much? 4 divided by final is 2. 4 by 2. 4 by 2 is 2. Log 2 value. Log 2 value, you remember, is 0.301. So, 2.303 by 10. 2.303 into 0.301 is 0.693 by 10. That means 0.0693 minute inverse. That is the answer here. So, depending upon the order of reaction, formula changes. And in the previous question, they have given rate constant, they have asked something else. And in this question, it is a different order reaction, they are asking us to calculate rate constant. So, see what is given, what is asked, which order the reaction comes under, and apply the right formula there and get the answer. Next, there is a rate constant given. Observe the units. Can you figure out which order this reaction comes under? See, what is the unit here? Second inverse. Second inverse is the unit of which order reaction? Molarity second inverse is the zero order. Here there is no molarity or moles per liter, only second inverse. So, which order this reaction comes under? First order reaction. How long it will take to consume 90% of reactant? 90% to consume, how much time it will take? Okay. Now, such problems how to solve? Initial concentration, let's take it as 100. Initial concentration you take it as 100. Whenever you are dealing with the percentage problems, start like this. Then final concentration will be 90% consumed means what? Reacted. If 90% is reacted, how much will be remaining? Out of 100, if 90 is reacted, then remaining, R is remaining concentration. How much that is? 10. So, like this, R naught you take 100, R you take 10 and substitute in the right formula. What is the formula of first order reaction? 2.303 time initial by final. Now, how long it will take they are asking. That means they are expecting the time value. So, let's take time here and bring constant here. So, what is the formula then? Time is equal initial by final. Initial R naught is how much we have taken? 100. Because percentage initially I begin with 100%, 100 molarity. Finally, it has become 10 molarity. Hundred by 10 is how much? 10 times. Log 10 base 10 is how much? 1. And K value is given how much? 2.303. So ultimately you will get what? 1. Is it minute or seconds? Look at the K value. K value is, what is the unit there? Second inverse. Therefore, our answer also has units seconds. So answer is seconds. 1 second it will take. Next, let's see another question. See, a first order reaction has a specific rate constant. Specific rate constant or rate constant, both mean the same. Sometimes they say specific rate constant. How much? 10 power minus 2 second inverse. Now again, here second inverse is there, means first order, and also they are saying first order. We need not struggle to find. It is already there in the question itself. If that is not there, then we will use the unit to know that. How much time will it take for 10 molarity of the reactant to reduce to 2.5? 10 molarity original, finally how much is there? Reduced to how much? 2.5. For that to happen, how much time it will take? So, let's first write the formula. K I am taking time left side, K right side. Okay. Now R naught. K is how much given? 10 power minus 2 is the K value. So see, K is given in the question as 10 power minus 2. R naught initial value is how much given? 10 molarity. Final reactant is how much? 2.5. So let's substitute these quantities in the formula. K is 10 power minus 2 log R naught means initial, R means final, which is 2.5. Now 10 by 2.5 is how much? 2.5 into 2 is 5 and 2.5 into 4 is 10. So it is 4 times. 4 times. And 10 power minus 2, if we take it to the numerator, it will become 100. 10 square means 100. Then it will become 230.3 log 4. Then how to solve? See, because that is not there in the options anywhere, log 4 is not there. We have to simplify this log 4 also further. How to get that? Now, see, log 4 we can write log 2 square. We can write this as log 2 square. Now, this power 2 we can bring it to the front side of logarithm. Then it will become 2 log 2. So let's simplify this further. 2 log 2, 2.303 into 2 log 2. Next, sorry, it is not 2.303. Here what? There is a point, decimal point after 3 digits. So it is 230.3 actually. 230.3. Now, what is the log 2 value? Log 2 value is 0.301. 0.301. So therefore, now 230.3 into 2 into 0.301. If you multiply these three quantities, that will be the answer, time. And what is the unit for that? See, what is the unit given for the rate constant? Second inverse. So therefore, we also get that many seconds as the answer. Next, let's take the another model. Now see, as I already mentioned before, among 0, first order, second order, which is the most important? First order. Most often if you see the previous year's questions, mostly questions are asked from the first order. So let's remember few formulas so that we can save our time in examination when we are dealing with first order problems. Already we know for first order what is the rate equation. Rate is equal to K into reactant power 1, because order is 1, reactant power 1. And rate constant formula is what? 2.303 by time log R naught by R. That is the rate constant formula. R naught is initial reactant, R is final reactant at time t. Half-life, it does not have any initial concentration term, simply 0.693 by rate constant. These three already we know. Remember the other formula, R naught by R, initial by final, is equal to 2 power n. 2 power n. What is n here? N is the ratio of T and T half. Now this formula will save lot of your time if we know T and T half both are known to us. We can get the n value and we can substitute here. So this will save lot of our time. Instead of going to this formula, like rate constant formula and half-life formula, we can simply use this to save our time in examination. So remember that. We will see some application on that formula in the next page. Next, T3 by 4. T 3/4 means what? 3/4 of the reactant is reacted. 3/4 reacted means we can say 75% of the reactant is reacted. Okay. Both mean the same, 3/4 reacted or 75% reacted. Now for this simple formula is 2 times of T half, 2 into T half. It is the time to complete 3/4 or 75% of reactant. Sometimes they say 3/4 completion time is 60 seconds. What is the half-life? 3/4 completed is 60 seconds means, can I say 2 times of T half is 60 seconds? Therefore, half-life will be just 30 seconds. So we can easily solve such problem by saving lot of time. Next, 90% completion. 90% completion time is what? Half-life by log 2. 99.9% completion time is what? 10 times of T half. So these formulas, because quite frequently they ask, when they ask percentage completions, 90%, 99.9%, most often you see 75%. So it's better to remember these formulas to save our time. See, half-life of first order reaction is given, T half. What is the amount of substance left after 1 hour? See, remember here what is the amount of substance left means what? Generally people think if a person is leaving the room, okay, we will say a person has left the room. So we are talking about person gone out of the room. But here in case of reaction, if they say what is the amount of reactant left, means it is not the reactant consumed in a reaction. It is the reactant present, remaining after the reaction. Keep that in mind. So they are asking about the substance remaining after 1 hour of reaction. If initial concentration is 2 molarity. So what information they have given? Initial concentration they have given. They are asking what is the final concentration remaining, and time also they have given. What else they have given in the question? Half-life is also given. Now, remember, when first order reaction you are dealing, then and T and T half, if both are given to you, then easy formula, simple formula to get the answer quickly is R naught by R is equal to power N, where N is equal to what? T by T half. T and T half, when they are given in the question, begin with this formula. It will save you a lot of time. Instead of going to logarithm formula, start from here. So here R naught is given. How much R naught? 2 molarity. R we need to find is equal to power N. N means what? T by T half. So T by T half, let's calculate. T is given as 1 hour. 1 hour means 60 minutes. T half means 20 minutes. So N is equal to what? 3. So let's substitute here N plus 3. Then if we cancel this 2, then you will get 2 square here. So R is equal to then what? R is equal to 1 by 2 square. 1 by 2 square means 1 by 4. So initially 2 molarity, but finally how much reactant is left remaining? That is just 1 by 4. This is how you have to solve these questions. I hope all this discussion helps a lot, helps you, and it saves not only time in examination, and this kind of questions, very simple formula based questions, and you will get answers quickly, and there is no confusion. You will get 100% answers also. So first go through this discussion once again and understand each and every point and all these models we have discussed, and practice these questions. Take the previous year's questions, especially from 2010 to 2023. You take these questions first and practice them, okay, related to orders. Then you will get more confidence also. Okay. All the best. Thank you.